Hello everyone. Welcome back to the session on SDP of Introduction to Arduino IoT and Simulation. Now, in today's tutorial, I will explain some programming concept related to Arduino and the IDE, that is Integrated Development Environment, which is required for the programming of the Arduino, that I am going to explain. Okay. So, what is mean by IDE? IDE stand for Integrated Development Environment, which is used to program any microcontroller. So, IDE is basically one software, one kind of software which we have to install on our system, and then through that particular software we can write program for the microcontroller. Okay, so for the Arduino programming, we are having one software which is Arduino IDE. Okay, so if you visit Arduino website, then on that website you will get this software. So I'm just giving a small introduction to this particular software. So the very first thing is whenever you want to design or you want to build projects using Arduino board, then in that case the very first thing is you will require hardware, that is Arduino board, and the second thing is you require this software. Okay, so with the help of these two things, you can start designing small projects based on Arduino. Okay. Now here is this particular GUI or GUI, that is graphical user interface of this particular software. This is called as IDE, that is Integrated Development Environment. It is having assembler, compiler inbuilt inside this particular software. Okay, so whenever you want to write program for the Arduino board, for example LED blinking, then very first thing is you have to click on File, then you have to click on New, and then after that you have to wait, and then this sketch will be open. Okay, and then later on you have to save this particular program using save as option or save option. So I'm saving this particular program on the desktop. So on the desktop I am creating one folder, let's say hi. Okay, and I am giving this basic program name and save. Okay, now in Arduino, please remember one thing: the program is basically called as sketch. Okay, so here we have saved our program. Okay, and here we can start writing our program. Okay, now for writing of the program, there are certain things like we have to declare variables. We are having one while loop. Okay, so here you can see we are having void setup. Okay, so here we can declare variables, as well as we can set baud rate. Okay, we can define GPIO pins, which GPIO pins we have to declare as a input or output. Okay, so all these things we have to mention in the void setup part only. For example, you want to design one project like temperature monitoring system. So in that case you have to interface one sensor to the Arduino board, and you also need one display device which you have to again interface to the Arduino board. Okay, so in that case that sensor will the sensor you have to connect to the one particular pin of the Arduino board. Okay, so in that case that particular pin, very first thing is you have to define that particular pin as an input pin. So that part is declared in this void setup. Okay, second thing is whenever you are interfacing display device, that display device you have to interface to certain GPIO pins, then these GPIO pins you must have to declare as a output. Okay, so all these things you have to first mention in the void setup part. Okay, and then in void loop is basically infinite loop. So whatever code you put here, it will continuously repeat. Okay, so it will repeat infinitely. Okay, so for example you want to monitor room temperature, then you will first read the value from the sensor using one GPIO pin, and you will put that value on the display device. Okay, and once you write that particular code into the void loop, then this code will be repeated continuously. Okay, now here one more interesting thing is in the file itself we are having some examples. Okay, so for example if I go to the file example and basics, then suppose I select this blink program. Okay, once I open this blink program, then you can see, for example, I will delete this, sorry. For example, this is a blink program. Okay, so I have taken this from the example. Now here you can see we are having void setup and void loop. Okay, so in almost every Arduino program we are having these two important things. First one is void setup and second thing is void loop. Okay, now in void setup you can see pin mode is declared. Pin mode means which pin you want to declare as an input or output. Okay, this is very important in designing any project, because normally we read sensor value and we perform certain operation on the actuator or display devices. So in that case, very important thing is you must have to declare that particular pins as an input or output. So here they have mentioned pin mode LED built-in output. So what they have mentioned is LED blinking means pin number 13 is having this particular built-in LED. So in the previous videos I have already explained there is one onboard LED which is available on the Arduino Uno board. So that is nothing but built-in LED, and this LED is connected to the pin number 13 of the Arduino board. Okay, so in this case pin mode LED built-in means pin number 13 and it is declared as a output. Okay, similarly suppose you want to declare particular pin as an input. Now this program is LED blinking simply. Okay, it means onboard LED will be in blinking condition. Okay, now suppose you want to declare one particular pin as an input, then you will write pin mode M capital. Then again suppose you want to declare pin number 3 as an input pin, then you will write in pin number 3 and then I and P input. Okay, bracket close. Okay, similarly suppose you want to declare another pin as a output pin, then you will write this, then you will write let's say 6 number pin and output. Okay, so in this way we can declare pins of the Arduino board as an input or output. Okay, now next is void loop. Now as this we have to write program for the LED blinking. LED blinking means we have to turn on LED, then we have to keep that LED in the on state for few second or few millisecond, then we have to turn off the LED, and then again we have to keep that LED in the off state for certain amount of time, and then again we have to turn on the LED. So in this way this LED will be in continuously blinking condition, that is on off condition. Okay, now please remember this thing, this LED blinking is nothing but equivalent to square waveform. Square waveform normally goes into on state, then off state, then again square waveform always stay in the on state and off state for certain amount of time. Okay, so this is nothing but the LED blinking. So here suppose you want to write 1, that is high logic, on that particular pin, then you have to write digital write LED built-in. Built-in means pin number 13 here we have declared, and high. So this LED will be in on state. Okay, then delay. So we have to keep that LED into the on state for certain amount of time. So for example 1000 here they have mentioned. Now whatever delay function we write and whatever inside this delay function we write, it will be considered in milliseconds. So 1000 millisecond is equal to 1 second. So your LED will be in on state continuously. Now please remember one thing, if you turn on LED and if you turn off LED immediately, then your LED will be not in blinking condition. Okay, because our eyes cannot differentiate between on state and off state if we are not providing delay. So delay is very very important. We must have to keep LED in on state or off state for certain amount of time. Okay, now then digital write LED built in low. Low means off state. Okay, so LED will go into the off state. Again we have to apply delay so that LED will be in off state for certain amount of time. Now as I have already mentioned, this is infinite loop, right? So this LED on off will be continuously in the infinite loop. So our LED will be in continuously blinking condition. Okay. Now once we write this program, then we are having this particular button which is verify. So first we have to verify whether our program is right or wrong. Now after verifying, it will compile this sketch, and here it will mention if there is any error, and if not error, then it will show zero error, zero warning. So first it will take some time. Okay, so here the sketch is compiling. Okay, and done compiling. Okay, done compiling means no error. Okay, now the next important thing is once you connect your Arduino board to the computer, then first in the tool you have to select that particular port. As of now I am not having hardware, so it is not showing any port. So once you connect this particular board to the Arduino to the computer or laptop, then here very first thing is you have to select that particular port. So once you connect that board to the computer or laptop, then it will show the port. Then you have to select that particular port. And second thing is you have to select board. Now here automatically Arduino Nano is selected. So if you are using Arduino Uno, then you have to select this Arduino Uno board. Okay. So very first thing is you have to write program. Then you have to verify the program. Then I'm explaining you the step. Please note these steps. These steps are very important. Very first thing is you have to write program. Then second thing is you have to select port. It is not showing right now because I am not in hardware. Then second thing is third thing is you have to select board, which board you are using, because so many boards are available. In the previous videos I have already explained there are so many boards available for the users. Then you have to select this Arduino Uno boards if you are using. Okay, so this is third step. Okay, first thing is write program, second thing is select port, third thing is select board, and then fourth thing is upload. So once you connect board to the computer, you select port to the through which your board is connected, and after that if you select board, then you have to click on upload. Okay, once you click this button, then this program will be converted into the machine code and it will be uploaded into the Arduino board, and according to the program your Arduino board will work. Now here it will show error because I have not connected board. I am right now I am not having any hardware. Okay, so this is just a small introduction to the Arduino IDE. Okay, so this is Arduino IDE. Okay, now in the next tutorial I will explain the machine code and some important part related to the programming of the microcontroller. Thank you.